Alright, so starting day 2 of pulleys, hopefully after completing your lab in class, you were able to get all of your mechanical advantages to a whole number and got to the right values, and then use that to come up with whatever the pattern is for figuring out the mechanical advantage of a pulley system just by looking at it. You actually don't have to do all the measurements that you did. You could just look at a pulley and automatically know. And that's what I'm going to teach you here today. The key to doing this is looking at the number of strings on the pulley. Alright? Now there's one exception to that. You need to ignore the one that you pull down. Alright? So if you remember a single fixed pulley, the video yesterday told you that the mechanical advantage was 1, and you also should have measured that in class. How you get 1 is you draw a line in the middle of your pulley system, and the number of strings that you cross tells you your mechanical advantage. Now you have to remember that that string that you pull down, that one doesn't count. So that's how you get 1. Alright? Then the single free pulley, yesterday you were told that the mechanical advantage is 2 in the video, and then you also should have measured that to be true in your lab. So again, you draw a line through the middle of your pulley system, and since you are pulling up, this one does count. So that's 1 string, and then 2 strings, and that's how you get 2. Alright, so let's apply this to some more complicated pulleys. So remember, string going down does not count. Draw a line through the middle of your pulley system. Alright, the middle of it's going to be the space in between the top pulleys and the bottom pulleys. So that's why I drew it here. So count the number of strings that you cross. 1, 2, 3. So the mechanical advantage for this is 3. Alright, now next go on to this other one. Remember, you don't count the one that's being pulled down. So draw a line through the middle of the pulley system, then count your strings. 1, 2, 3, 4. Mechanical advantage for this pulley is 4. Alright, if you were doing your lab correctly, these are values you should have gotten for the pulleys that you did. So let's apply this to... So, given the pulley pictured, if the pulley lifts the object 0.5 meters, how far did you pull? So, it's telling you that this object is going to go up 0.5 meters. You're going to pull it down, but we don't know how far. Alright? So if you think back to LSU, our knowns are dr. What the machine does is 0.5 meters. What you do is our question mark. Based on that alone, it appears that there's not enough information to figure this out. Except you can go to our new mechanical advantage rule when looking at a pulley. So draw a line in the middle of the pulley system and then count how many strings you cross. So 1, 2, 3, 4, 5. So that tells us mechanical advantage is 5 for this pulley. So MA equals 5. Yesterday, you learned a new mechanical advantage equation. So mechanical advantage is also equal to your effort distance divided by your resistance distance. Alright, and if you want to find dE, you just have to multiply by the dr to get rid of it. So it's going to be MA times dr. Okay, so let's plug in our numbers. We've got dE equals 5 times 0.5 meters, which you will solve to be 2.5, and since you're solving for a distance, your units are meters. So 2.5 meters. You'll pull down 2.5 meters, and since mechanical advantage is 5, it only goes up 1/5 of that, or 0.5 meters. Okay? You can also do this to our original mechanical advantage equation. Alright, so let's think back on that one again. I'm going to move this off to the side here. Originally, we learned that mechanical advantage is equal to FR divided by FE. Alright, that's still true. So sometimes if you can figure out a mechanical advantage and it gives you one of the forces, you can figure out the other. All right, so let's rearrange that. If we want to, say, solve for FR, we need to get rid of FE. So multiply both sides by FE. That cancels out. FR equals MA times FE. All right. You can also do same thing, but to solve for FE, you start out with the same first step. All right, multiplying both sides by FE. Sorry, that got a little crunch there. So you'll have MA times FE equals FR, because you can't solve for FE if it's in the denominator. And then there's just one more step. You have to move the MA over, so you divide by MA. So FE equals FR divided by MA. So these are equations you can use as well. Okay? So let's go back to this problem and start applying that. So, sample problem. Given the pulley pictured, if you apply 150 newtons of force. So here's you, and your FE is 150 newtons. What is the weight being lifted? Remember, weight of the object is your FR. So that's our question mark. So we know that FE equals 150 newtons. If we use our new rule, we can figure out MA. There's 1, 2, 3, 4, 5 strings. So MA equals 5. Mechanical advantage is 5. And FR is our question mark. I'm going to go back to our original mechanical advantage equation, which is FR divided by FE. If we want to solve for FR, you just have to multiply both sides by FE to get that out of the way. So FR equals MA times FE. So we're going to plug that in. R equals 5 times 150 newtons. And that ends up giving you 750. Since you're solving for a force, your units are newtons. Okay. So these are some new applications that you can use when given a picture of a pulley and using our new rules for calculating or just looking at the pulley and figuring out the mechanical advantage. So take advantage of that new knowledge. You do have an online assignment that you need to get done by tomorrow morning at 7:20 a.m. and I'll see you in class.